Okay. So, can you hear me?
Yes, we can
Hi.
hear you. Maybe you want to launch your slides as well?
Yes, I'm on it.
While Pierre is getting ready, if anyone in the audience has been inspired, especially today, to talk about something, after Pierre's talk, there is still time for a lightning talk. We can have it here on the stage, or we can just go outside in the lounge and hang out and talk about a lot of different things. But if you want to come on the stage after Pierre, please message me on the side and I will arrange it. So yes, we have Pierre Stritzinger with us today also, conveniently coming right after a GRISP talk. But this time he's not talking to us about GRISP, apparently. He's talking to us about a debugging tool that comes with Erlang OTP, and I just learned exists after many years of using Erlang. So
Yeah,
Pierre,
that was
the stage is yours.
Yeah, thank you. Thank you, Stavros. Yeah, happy to be here. Yeah, I was actually like thinking about a lightning talk call topic for a while, and then really about 2 weeks ago, I stumbled upon something. I actually I actually misunderstood a Python feature, which I read on Twitter, and then kind of like when the misunderstanding cleared, because I thought, yeah, I want this in Erlang. And I asked about this on the Slack, and kind of like when I clarified what I actually want, then I got a message from a member of the OTP team, which pointed me to a feature that has been there since a while. I checked back until R16, and it was already there in R16. So that was not the first Erlang version I used. I think I started with R11 14 years ago, and I was not aware of this feature. So it's a debugging feature. So let's look like to have a bit of useful learning content here. Kind of like we have lots of useful debugging tools in Erlang. There's a debugger, which I kind of like shaded like slight gray because it's actually not really useful, but it's there. But if you want to debug concurrent things, then a single stepping debugger is not useful, because once you stop one of the processes, everything else times out around you and then you're in hell. There's logging, there's tries, which lets you actually inspect the Erlang VM itself and trace. There's the observer tool where you can actually inspect your system. If the Erlang system goes down, you get a crash dump. So there's crash dumps, and there's crash dump viewer, which is part of observer, and other tools. Lots of tools and techniques are talked about in this URL. So actually save this URL. That's a lot of interesting things. There's quite recently open telemetry, which kind of like gives you a lot of insights in your running system, which also help you debugging things. The most important one is debug tracing. That's why I put it in the middle. So basically, should we have like newcomers to Erlang in the listening to this talk, learn about debug tracing. It's the most useful thing. It's basically the built-in debug. There's BIFs that do this, and there's libraries that actually help you. An older one, Redbug, and a newer one, Recon, from the author of this, from Fred, which gives you a nicer user interface. There is also, of course, I/O format. I kept it to the last, but you shouldn't do this. So this is like, don't do this. Don't do this for debugging, because rather learn debug tracing before you start plastering your program with I/O formats. So what is missing here? In embedded systems, we often have a ring buffer of kind of like very low-level things where you can actually stuff a few pointers or stuff a few values in there to actually debug down to really like the interrupt level, because you can make it very simple, and it's just a kind of like an array where you cyclically store stuff. And then when your program crashes, then you can actually look at the error in the debugger to get some kind of like backtrace information about what actually got the program here where you are, which is sometimes useful. It's more than a stack trace, because a stack trace only shows you the layers of the calls into the stack, but these are actually the calls that happened, or the information that you actually decided to trace. And I basically some hardware debuggers also have this built in. They trace the system and they do a ring buffer. We have tracing, but tracing needs to be set up, and it's a little bit dangerous to use in production. So what did I discover? The one more debugging feature. There is a process flag, save calls, which takes a number, which actually sets the size of the ring buffer, which is actually built into OTP. And then when you can actually, at any time, you can actually use process info, either just process info, then it's part of it, or you basically can pass the thing that you actually want to know about, last calls, and then it returns a list of tuples, module functionalities, of all external function calls, so not the local ones, and or the atom send, receive, or timeout for basically send messages, received messages, and timeouted. You don't see what messages, but you know that it happens. It also goes into the Erlang crash dumps, and Observer also shows it. So let me give you a short demo of this. So I need to actually stop share and share my terminal. So this is the right terminal, I think. So you see my terminal? Yeah, you see it. I see it myself. So we just start an Erlang process. So which process do we debug? The most convenient one around, the shell. So what we set is basically we call process flags. We don't need to tell which process. Save calls. And let's say we don't want a long list. The last 32 calls. It could put 1,000 here. Oh, that's the error I always make. It's actually process flag. We're setting one process flag after all. And it gives you back the old value. So it was set to 0. So now when I do process info, self, because there I need to tell it which one, about myself, last calls. Then I get this list of tuples, and we see it actually calls Erlang internal BIF, GB sets, ord sets, is element, list member. So that's kind of like the stuff. And I made the list too long. So let me show you the full list. So the last one is actually Erlang process info. That's the last call we did to actually get this list. So one more thing to show you. Oh, no, that was a mistake. If you have time for that. So we do process flag again, and then we do observer start. And I also ask it for self here to actually know which PID we're actually looking at. And now I need to show you yet another window, namely the observer window. I don't want to share my whole screen because it's too large, then nobody can read anything. So basically observer shows you this, and you can go to processes. And now we know that we are looking at process 79. Oops, sorry, misclicked. So we want to sort by PIDs, and it's 79. So this is the shell. So we double click it, and here we have the last calls. Last calls, send Erlang, but it doesn't show you many calls. But at least you see the last calls, it's shown.
It is likely that you see some different window than we are seeing. We are stuck on the main window of the observer.
Oh, why did it do it? Oh, it opens another window. I'm sorry.
Yes, exactly. And I was ready to come on the screen as you were about to double click predicting this.
Yeah. So that's the window that actually popped up, because you can look at multiple. So you see the last calls here, the entrance of this thing. So now we lost Stavros. That's thing. So I need to take over what. So yeah, that was it. Stavros, you were muted.
No, I'm not.
No,
you're not. Yeah.
It was just hiding. It's a feature of Reach. You can hide.
So actually, a question to the audience: who knew about this feature before? Brujo did, of course. Anyone else? No. Okay, so I don't feel bad about not knowing about this. But I do so know it's very useful.
It's pretty clear that you
Yes, exactly.
had a lot of pain in debugging systems and finding.
I was tempted to start a poll about how many are actually using IO format, but I decided against it because that would get us a bit depressed, I think. Any questions? Brujo wants to come on the stage.
So yeah, Erlang tracing tools, there are many hidden secrets there. Let me show you one of them. Need to open it up in a small window first, otherwise it will be unwatchable for people with wide screens. And this is this one. Do you see my GitHub? Yeah.
We do.
Okay. So ET. And of course, you have this amazing function here. And you can do ET phone home.
It is obligatory.
It's obligatory, and it does come with OTP. It just does nothing, so you can trace. If you want to trace something, you can trace ET phone home.
Cool. We got a question for Pierre. So one can clearly use this with an RPC call to get info from Chris.
By whatever means. Actually, I searched the OTP code and looked where it's actually used to actually find out where I could actually get at the info. What's actually, I think, missing is if you get a stack dump, like a crash dump, then it should be actually added there too, I think, by default, if it's not empty. That would be a nice feature, and I'm actually working on a pull request already, maybe.
Great. Okay. This was the last scheduled lightning talk. I haven't received any signals about somebody wanting to come to the stage here. So I guess we can conclude the last session of the workshop and then head back to the lounge and continue discussing in one of the tables. So great. Thank you very much all for being here today and joining us in this second virtual